Hey everyone, Double Time here. Today we're going to be going over derivative rules. Now, if you're here, you're probably studying for exams, so to not waste your time, we're going to get started. So, we have 4 different sets of derivatives we're going to be going over. Those are going to be the standard ones, the trigonometric derivatives, the exponential ones, and finally, the logarithmic derivatives. Now, to start us off, we have the old-fashioned constant rule. The constant rule states that if you ever have a constant and you're taking the derivative of it, it's always going to be 0. So, for an example, we have the derivative of 4 in terms of x, and that's just going to be, you guessed it, 0. So, moving onwards to the constant multiple rule. So, anytime you have a function multiplied by a constant and you want to find its derivative, just take the derivative of the function and then multiply it by the original constant. So as an example, we have 4x. If we took that derivative, we would get 4y. Well, the derivative of x is 1 times 4 is just 4. So now we have the power rule. The power rule states that anytime we have a variable to the nth power and we want to find its derivative, we just take that constant n and multiply it by x to the power of n minus 1. So for example, we have the derivative of x to the 4th power. What we'll do is we'll take that constant 4, drop it down, and multiply it by x to the 4 minus 1, which is just 3. So then we will result in 4 times x cubed. So now we have the sum and difference rule. The sum and difference rule basically states that anytime we have a function added or subtracted by another function, and we want to find the collective derivative of those terms, what we can essentially do is just independently take the derivatives of the f function and the g function and add or subtract them accordingly. So for example, we have 4x squared plus 3x. If we want to find its derivative, we will just take the derivative of 4x squared, which gives us 8x, and then we can add the derivative of 3x, which is just 3, resulting in 8x plus 3. So now we have the product rule. The product rule states anytime we have a function multiplied by another function, f and g, then we will be able to find its derivative by taking the derivative of f times g plus f times the derivative of g. So for example, we have 4x squared times the natural log of x. If we want to find its derivative, we will first take the derivative of 4x squared, which is 8x, and then we will multiply that by the natural log of x, and then we will be able to add 4x squared times the derivative of the natural log of x, which is 1 divided by x. And then if we want to simplify that, we can reduce, resulting in 8x times the natural log of x plus 4x. So now we have the quotient rule. The quotient rule states that anytime we have a function f divided by a function g, if we want to find its derivative, what we do is we take the derivative of f times g, and we subtract f times the derivative of g, and we divide this whole set by g squared. So, for example, we have the derivative of the natural log divided by x squared. In this case, f is going to be the natural log of x, and then g is going to be x squared. So, if we want to find the derivative, we take the derivative of the natural log of x, which is 1 divided by x, and then we multiply that by x squared, and then we subtract natural log of x times the derivative of x squared, which is 2x, and then we divide all of this by x squared squared, which is x to the 4th power. Now, to simplify this expression, what we can do is we can reduce the x terms, resulting in x minus 2x times the natural log of x, all divided by x to the 4th. We can then factor out an x, and then we can reduce, resulting in 1 minus 2 times the natural log of x, all divided by x cubed. Alright, so now we have chain rule. Chain rule basically states that anytime we have a composite function or a function within another function, we can find its derivative by taking the derivative of the outer function in terms of the inner function multiplied by the derivative of the inner function. So, for example, we have the derivative of the natural log of 4x squared. The derivative of natural log is 1 divided by x. If we put it in terms of 4x squared, we get 1 divided by 4x squared. And now we need to multiply this by the derivative of 4x squared, which is 8x. And if we want to reduce the x's, we get 2 divided by x. Alright, now we're going to move on over to trigonometric derivatives. So to start us off, we have the derivative of sine is equal to cosine. The derivative of cosine is equal to negative sine. The derivative of tangent is equal to secant squared. The derivative of secant is equal to secant times tangent. The derivative of cotangent is equal to negative cosecant squared. And then finally, the derivative of cosecant is equal to negative cosecant times cotangent. So now we can do our exponential derivatives. So whenever we have a constant a to the power of x, and we want to find its derivative, all we have to do is take the natural log of that constant a times that constant to the power of x. So for example, we have the derivative of 4 to the power of x. And if we want to find this derivative, we just take the natural log of that constant, which in this case is 4, times 4 to the power of x. And then also we can learn how to do the derivatives of e to the x, which is just e to the x. So if we have the derivative of e to the 4x in terms of x, we can invoke chain rule with our knowledge of the derivative of e to the x and know that the derivative of e to the x is e to the x. If we invoke chain rule, we can supplement that 4x in place of where the x would be, and then we can multiply by the derivative of 4x, which is just 4. So now we can do our logarithmic derivatives. So anytime we are taking the log base of a constant a, its derivative is going to be 1 divided by the natural log of that constant a times x. So for example, we have the derivative of log base 10 of x, and that's just going to be equivalent to 1 divided by the natural log of that a, which is 10 in this scenario, times x. And then also we can learn how to do the derivative of the natural log of x, which is just going to be 1 divided by x. So, for example, we have the natural log of x squared, which its derivative will be 1 divided by x squared times 2x because of chain rule, since we have to multiply by the derivative of the inner function, which is just 2x. And then if we want to simplify that, we can get 2 divided by x. Alright, that just about wraps it up here. To finish it off, I'm going to show all the different derivatives we just learned, so that way you can review and study them. And I hope you all have a great time with your exams or whatever you're trying to do. And I'll see you guys later. Thank you very much.